Today we are going to answer the question, why is the area of a triangle 1/2 base times height? Well, first things first, what we want to focus on is what is the definition of area. The area is the number of 1 by 1 squares in a unit. So right here we have our first thing we are going to be focusing on is how to find an area, or why this equation works in a right triangle. Okay, so we'll look right here. We have a right triangle. Well, first we should define what a right triangle is. A right triangle is any triangle that has a 90-degree angle in it. So we see that this right here, this triangle has a 90-degree angle, so we know that it is a right triangle. So now we need to label the base and the height. And the base of this triangle is right here, and the height is here, because this vertex is above the base. So we know that the height will go perpendicular to the base to make a 90-degree angle. So that's why this is the base and this is the height. So we defined area as the number of 1 by 1 squares in a unit. So basically simple, okay? So I have this triangle drawing out. So now all I need to know is how many squares there are. So if I were to draw it, I could go like this. Disregard that they might not be perfect because I am human, so there might be some error. Okay, so we have those. But now you notice that these are kind of hard to draw, right? It's kind of hard to know, well, how can I add these up? It doesn't seem like they all match up. So what do we notice about a right triangle? As we added these boxes, we know that it kind of looks like a rectangle. If we drew a rectangle here, right, we would be able to, and we drew a line right here, what do we see? We see that same right triangle that we drew right here, right? So, and what we also know is that a right triangle, the equation or the area of a right triangle is the length times the width, right? So now if we were to draw this, we're trying to find the area, so the number of 1 by 1 squares in this. So we know that it's 3 by 5 or 15. Now, like we mentioned before, if you look at this rectangle / square, we notice that the triangle is half of it. So if the area of a square is going to be length times width, or like the base times the height, we know that our triangle is half of it. So that's why the equation for a right triangle is going to be half base times height, because the equation of the square is base times height, or length times width, and that triangle is half of it. So that's why it works on right triangle. But now what happens if we get a triangle that looks like this? Well, first we need to be able to label the base times the height. So basically we know that this is the base, right? However, how can we do the height? If we did the height here, we know this is the tallest point, so we'd want to measure it, but it won't be equal. So we're going to need to break this up here and break it into two right triangles, right? Because the height is perpendicular with the base. So this would be the height. So we break it up into two right triangles, which we defined as triangle with an angle of 90 degrees in it. So we need to find now the area of both of these triangles. So to separate these triangles a little bit, we're going to break the base up. So it's going to be x and y, because they do have different bases technically, because they're two different triangles. So we know that x plus y equals the base. So now, in order to find, we'll call this triangle number 1 and triangle number 2. We're going to find the area, which again is defined by the number of 1 by 1 squares in a unit. So because we already figured out why this 1/2 base times height works for a right triangle, it makes sense why we would want to break up this triangle into 2 right triangles, because we already figured out that it works. But now we're going to make sure it works with having 2 right triangles in it. So for triangle 1, it is going to be here 1/2 x times the height, okay? So now for triangle number 2, we're going to pretty much do the same thing, except it's going to be 1/2 y times the height. Okay, well, so now we don't want to just find the area of these 2 different triangles. We want to find it for the whole. That's what our goal is in the end. So in order to find it for the whole, we are going to do 1/2 xh plus the area of the other triangle. Well, we know that we have 1 height in there, so we only need 1 h technically. So then we'll combine these. It'll be 1/2 h, because it's multiplying by the y and by the x plus y. Well, to simplify that, what did we know x plus y is? X plus y equals the base. So our equation ends up being 1/2 height times base. So basically now we know with this equation, 1/2 base times height does work. We did have to break up our triangle into 2 right triangles according to our definitions of area and right triangles, but we know that this equation not only works if it is a right triangle, it works for a triangle like this. Okay, well, now we are going to get a little bit trickier, and I am going to give us a third triangle, because we want to make sure that it's going to work on more than one triangle. Okay, so finally our third triangle is going to be a triangle that looks like this. Pardon that triangle, it's a little goofy. So what we are going to do is, again, like we did in this triangle, we don't see, there is no right triangle in it. So we want to make sure that we have the correct base and height. So that again is by breaking this triangle up into 2 different triangles. So we know that this is the base, okay? And so our height should be perpendicular to the base. Well, if I put it here, you can't just put it right here, because that's not getting all of it. Like, you're missing this big chunk. So I want to go to the highest point, and I'm going to go down, and we're going to add a new triangle. And here's a right triangle we will have in it. Okay, so first we are trying to add, first we will label this B, because this thing is B, right? And we have to label, and this is the height for the big triangle, this is the base, right? But now for the little triangle, we're going to label this X, because this is the height and this is the base. So for the big triangle, I'll write it here, right? Our equation will be, right, 1/2 of this times x, because we have to include the x, because now that is part of our whole big triangle because of the height, x, plus the b, right? We need both because we're adding both triangles, times 8. So that's the equation. So that's what for the the big triangle to look like. Now for the little triangle, this will be our equation. It'll be, right, just normal 1/2 h times x. So now basically we have our big triangle. That's the whole thing, our little triangle. But our goal was to find out the triangle, this triangle here, right? Because that's what we started out with. So because both of these are combined, what we are going to look for is the triangle we want. We are going to use both of these equations, right? So we have 1/2 x times b, right? Minus 1/2 x times h. So basically that is going to give us, for the desired triangle, 1/2 base times height. So again, we get that equation. We had to form a right triangle because, again, our definition of right triangle is the area of, or when a triangle has at least one 90 degree in it, and we have found the area, which is defined as the number of 1 by 1 units in a or the number of 1 by 1 squares in a unit. And the reason we break these up into right triangles is because in our very first example up here, we figured out why we use 1/2 base times height, and then the other two were how it works with other examples or other triangles that are not 90 degree triangles, and we figured that out by breaking them up into smaller 90 degree triangles, and that way we were able to make equations, and in the end our equations always led us to this 1/2 base times height. So now you see that this is why we use the area 1/2 base times height for all triangles, because it works, and we have figured out why it works by the steps that I just showed you. So I hope now you can create your own triangle using the steps and information and definitions that I gave you and figure out that it does work, in fact, for any triangle.